curious, do you guys have any input for me and for your classmates, remembering back when in Algebra 2 or Algebra 3 you did multivariable systems? What do we want to do here, or what's helpful to know? Share out some of those ideas that you talked about. I heard good conversations, so I know there are some ideas out there. Carrie, you want to tell us what your group said?
We said that you have to solve like each variable individually and then plug it back in. And so we thought that you could take the first and the third equation and get rid of the z.
Oh, okay. So you're going to take one variable at a time, which I always think is a super helpful approach. Don't bombard yourself all at once with that very first, like, oh, I gotta get all three. No, find one first. And you guys looked and said first equation and second, or first equation and third equation, z is ready to eliminate. So one thing that I often told my students, and that I do in my notes, is I label my equations. I call them A, B, and C. That's only so that, like, when I'm talking about the first and the second equation, I can just call them A and C. And I write it down in my work so that if I'm going back and looking for a mistake, I can tell Hannah, well, I was started with A and C, which means the first and the second. It's really easy to identify what is what. So I'm okay with what Carrie says. Let's stack A and C on top of each other. Z is ready to eliminate. And you get a new equation. I always call that new equation D right there. Okay, I have equations A, B, and C, and now I have a new equation, and it looks something like 3x plus 5y equals 0. So I think we're off to a good start. Joe, what else did your group talk about? Anything similar to this, different? Okay, what would you do when you got to this point then? Oh, you didn't talk to each other? You guys have so much knowledge, you should talk to each other. Share your ideas. If you talk about math, you're going to get better at it, all right? So it's important for you guys to have those conversations. So Joe doesn't have a lot to say about that. What about Hannah? Did you guys say anything else?
You pick like two other equations and cancel out another variable.
Pick two other equations and cancel out another variable. Which equations would you choose?
A and B.
A and B. And you would eliminate?
The x, you can just multiply b by -2.
Eliminate x. Multiply b by -2. I'm going to ask you this question. Did you do the same first step that Carrie did? Did you eliminate z and A and C? No, you didn't. Okay, so is this what you're telling me, like your first set of elimination or your second set of elimination? It's what?
That was my first.
That's your first set of elimination. Okay, so what I would say about what Hannah's going to do right here is, this is okay, and this is her first set of elimination. So remember, we can all solve the equations differently. If we leave A alone, and we multiply B by -2, we will still eliminate a variable and get a new equation, this time 8y plus 7z equals -3. That's a 7. It's kind of like a 2. And we could call this a new equation. Would we want to do Hannah's step after Carrie's? No. Faith, you're shaking your head no. Why? Why is getting this, let's say if we called this E, why is that equation E not helpful to our other equation? I agree with you. It's not helpful. Why? Okay, can't plug it into the other one. No way to solve for the variable with those two. Can anybody expand on what Faith is saying? Why is that particular step not going to be helpful to us, Blake?
She wanted to do elimination again. You can't because these are.
Oh, so if you took D and E and you wanted to like set that up as a two variable system, which we covered yesterday in 7.1 and 7.2, and you wanted to do the process of elimination, it's not really going to work out for you because you don't have the same two variables. So we have X and Y in equation D, we have Y and Z in equation E. So let's kind of reformat Hannah's statement about what we would do after, and I don't think that her statement is necessarily a wrong statement to say what she would do after Carrie. It's just they're working their problem differently, so maybe we're getting different results there. Hannah originally said, choose two other equations and eliminate another variable. How could we specify those directions or change those directions to help us out, Carrie?
You could take equation B and C and multiply C by -3, and you can get rid of the Z's again.
So you say take B and C times -3 and eliminate Z again. So if we were saying something to someone who'd never solved a three variable system before, I think it would be really important to note that you want to eliminate a variable twice, but really important, you want it to be the same variable. So when Carrie decided to choose A and C and eliminate Z, Carrie would know that in the second set of equations, and Bruno, you want to put your phone away? In the second set of equations she chooses to eliminate, she also wants to eliminate Z. Now, Hannah can go on with her work in the blue, but Hannah's going to choose two more equations, and she's going to eliminate X again, right? So it's important that you choose to eliminate the same variable twice. Since Carrie gave me hers, I'll go ahead and work with Carrie's equations. I'm going to multiply C by -3. If I add those down, then I get something like -2x minus y equals 5. And this I'm going to call equation E. This is Hannah's work, which is okay work. It's just she has to solve it differently. What did I do wrong?
Wouldn't it be -5y?
Yes, it would be -5y. Thank you. Hannah's work is okay. I'm going to cross it off only because it belongs to a different solution, right? Where if I was going to solve with Hannah's method, I'd have to choose two more equations and eliminate X again. So now we're to that point where we can take D and E and we want to eliminate a variable. What variable are we going to eliminate in this two variable system? Y. Y is ready to go. So I don't have to multiply D or E by anything. So over here I'm going to stack D and E on top of each other. 3x plus 5y equals 0. So Carrie, that was a really good pick. That worked out nicely. Okay. Thank you. We like doing least amount of work possible. Add down to get x. My y's are going to cancel, and I have x equals 5. After you find your first variable, this goes back to, I think also what Carrie said, like, we're just going to solve for one variable at a time. So now we have x. Let's pick a new variable. We're going to solve for y. In Carrie's work, we would solve for y first because we have y in the two variable system. Remember, if Hannah had gone through with her work eliminating x, then she would have solved for either y or z. And let's say she solves for y first, then she'd plug back in, find z. So she would be finding the coordinates in a different order. Okay. Let's see, I'm going to move this down so I have a little bit more room. I'm going to plug into my first equation, so 3 times 5 plus 5y equals 0. That's 15 plus 5y equals 0. 5y equals negative 15. So y equals negative 3. Okay, so this is work from yesterday at that point. You've solved for x, and you just plug it back into one of the equations, d or e, and you solve for y. Okay. Is that the end of your answer? Jordan, you're saying no, what else would I have to do? You still have to find z. Your answer now, because you have multivariable, is going to be an ordered triple. So you're going to take x is 5, y is negative 3, and you're going to plug it into any one of the original equations. And it wouldn't matter which one you plug into to solve. I'm going to plug it into the first one. 2 times 5 plus 4 times negative 3 plus z equals 1. That's 10 minus 12 plus z equals 1. Negative 2 plus z equals 1, so z is 3. So I'm just doing back substitution and simplifying that so I can solve for z. So my final solution should be 5 comma negative 3 comma 3. X, Y, Z ordered triple. Any other helpful things from previous math classes that you want to add to solving multivariable systems before we move on? Best thing I can say on a problem set, on a quiz, on a test, please show your work, and please be really neat about it. It's super helpful to me if you also use some kind of labeling system, only because like if you don't label something and then you multiply an equation by 3 and you never show me what you did, it's really hard for me to tell what equations you're working with. So it's best if you can show some kind of work for problems. Okay. Next example, I'm going to just kind of give you some time to jot it down and get started on it, and then we'll have a discussion about what happens. So jot down this 3-variable system, sort of think about it, formulate a plan, try something, see what happens. I'm going to break in for just a second to kind of talk about things. If I label my 3 equations, not everybody might have done this, but did anybody notice to start off like something that's helpful that you might make a mental note of to kind of reduce the amount of work you're doing, Emily?
They technically already has y canceled out.
Yeah. Equation A is just x plus 2z equals 5. So I'm thinking, like, in terms of that whole idea, I want to eliminate variables to create a 2-variable system. Well, I already have one equation that's only x and z, so I'd like my other equation to be only x and z. So when we choose to eliminate a variable, we might choose to eliminate y and b and c. So I would start with b and c, and you didn't have to do this. We want to eliminate y. Will we have to multiply either equation by something to eliminate a y? Multiply one of them by negative 1. And it doesn't matter which one you choose to multiply by negative 1, but I'm going to multiply b. So I get negative 3x plus y plus z equals negative 1. Then I stack c right underneath it. 6x minus y plus 5z equals 16. And then I'm going to add down to make my equation d. I'm going to get 3x, my y's will cancel, plus 6z equals 15. And you know, as I walked around the room, most people started with that. So I'm guessing most people saw what Emily had seen, that had only 2 variables, and we'd like to keep it that way. So when I stack d underneath, I have 3x plus 6z equals 15. I need to now eliminate another variable. We can choose either variable to eliminate. Ethan, what would you do to eliminate a variable?
Multiply one of them.
Multiply by,
-3.
yeah, probably negative 3a will work best. So then we get something like negative 3x minus 6z equals negative 15. And some of us are to this point where when we stack and add those, we find out everything cancels. You get 0 on the left, be a 0 on the right. What does that mean from our discussions yesterday, Ruud?
Infinitely many.
Infinitely many solutions. So we can make note of that. Infinitely many. Do we stop there? No. We will find the ordered triple where we have all the x, y, z's related by some value. Remember yesterday I let x equal a? That would be totally fine. Today, if you want most of your answers to match the back of the book, if you check your answers in the back, then let z equal a. It doesn't really matter which variable equals a. Okay, so I'll just say that like if you want your answers to match the back of the book, aside for one of them, let z equal a. Okay, so I'm going to say infinitely many like Ruin said, then let z equal a. So now I know in my ordered triple, the z coordinate is a. I'd like to find the x and the y coordinate in terms of a, so that they're all related to one another. So I'm going to go up to equation a, x plus 2z equals 5. And where z is, I'm going to substitute in a. So that's really x plus 2a equals 5. Subtract the 2a so that I get x all by itself. I have 5 minus 2a. If my z coordinate is some a value, my x coordinate is some 5 minus 2a. So let's say my z coordinate was 1, then my x coordinate is 3. If my z coordinate is 10, then my x coordinate is negative 15. Because I'm just relating them to each other. Then I still want to find y. So I'll take these and plug z equals a and x equals 5 minus 2a into one of my original equations. You'll have to choose either b or c. Because they have y in them, I'm going to choose b just because it has smaller numbers. So I'll say 3 times x, but x is really 5 minus 2a. Minus y minus a is equal to 1. So I'm just playing a game of substitution there. Subbing in my x, subbing in my z. Distribute 15 minus 6a minus y minus a is equal to 1. I've got some like terms here. Negative 6a minus a is minus 7a. So 15 minus 7a minus y equals 1. And then to get y all by itself, I'm actually going to add y to the other side and subtract 1. That will make it a positive y. So if I add y and then I subtract 1, I'll get 14 minus 7a. So that's my y value. So your ordered triple looks something like this. Was this the class where someone asked, like, could you have just let it be x? Did someone ask that question yesterday? What are you doing there? No. Maybe turn it on so they can't not doing that fun. Nobody asked that question yesterday? Oh, okay. Then I'll leave it be. There, like, know that it's not wrong if you say let x equal a, and then you find z and you find y in terms of a that way. Your answer will look slightly different, obviously, because instead of your z coordinate being a, your x coordinate is a. But the way that you solve for y and z, you'll have different expressions, but they'll still be correct. Okay, so you can use either one. Okay, the last example that we want to talk about today is a non-square system. And in a non-square system, we're talking about systems where the number of equations does not match the number of variables. When the number of equations doesn't match the number of variables, that makes it really difficult a lot of times to actually find the values of the three missing variables, x, y, z. So we're going to see something very similar to what happened on that last problem when we got infinitely many solutions. When we get to sort of that wall where we can't do anything else because there aren't enough equations, then we'll let one variable equal a. And we'll kind of back sub in that a and solve for the other two variables. So in this system, I really have only an equation a and b. You know, going back to Carrie's idea in her group way back at the very beginning, we would like to eliminate a variable one at a time so that we can solve for them. Which variable do you want to eliminate here? X. So we're going to do negative 5a and b. That'll be negative 5x plus 15y minus 10z equals negative 90. B will be 5x minus 13y plus 12z equals 80. And when I add those, my x's will cancel. I'll get 2y plus 2z equals negative 10. And that will be my new equation D. And this is where you kind of hit a wall, right? What else are you going to do? There's no way to get a second equation because we only had 3 equations to start with. So at this point, let one of these variables equal a. You can let y equals a. That's fine. I'm going to let z equal a. I'll accept your answers either way. If you want your answers to match the back of the book, then you need to let z equals a for the most part. Okay. So that gives me 2y plus 2z, nope, 2a, my substitution, equals negative 10, and solve for y. We get 2y equals negative 2a minus 10. And divide by 2, so we get negative a minus 5. So I now have a z-coordinate is a y-coordinate is negative a minus 5. Plug it back in to solve for x. You'll plug in a for z, you'll plug in negative a minus 5 for y. So right now we can't really pin down what that is, but we know it's those expressions. So x minus 3 times negative a minus 5 plus 2 times a equals 18. I'm plugging back into equation a right there. That's x plus 3a plus 15 plus 2a equals 18. And so that would be x equals, this will be 5a, but I'll have to subtract it to the other side. So negative 5a, and then subtract 15 will be plus 3. So I get negative 5a plus 3. So in a non-square system, you know, in Algebra 1 or Algebra 2, we might just stop and say, well, we can't really solve. We don't have enough information. Now we're going to say we can't necessarily pin it down, but we can find expressions for the x, y, z. We don't have the actual value, but we can find some expressions for those. These things will work. Any questions there? Okay, here is your assignment.